Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on frequency tables. So frequency tables are very useful when we have lots and lots of data points like this here. There are 29 scores and we're going to put them in a frequency table to organize the information. So if we want to put this information in a frequency table, it looks like this. So we have one column for each score and one column for the frequency, which is how many times the score occurred. So let's put this data into this frequency table. So we can see that the score 3 occurred once, so we put a 1 there. There were 3 scores of 4, 2 scores of 5, and so on. So at the bottom here, we write sum of f. That's what that means here. That means the sum of all frequencies, which is 29. This is how many scores there were in total. So in this column, fx means f times x. We times the score by its frequency. So here in the first one, we go 3 times 1, 4 times 3, 5 times 2, and so on. So after putting in these numbers here, we usually add them up. So if I add up the fx column, that's what this means here. The sum of fx, I get 215. 215 is the number I would have got if I added up all of these numbers. If I went 3 plus 4 plus 4 plus 4 plus 5 plus 5 and so on. You can see that doing it this way, adding up all of these numbers would take forever. This way just makes things a little faster. So if I wanted to calculate the mean of this data, remember the mean is all of the scores added up divided by how many there are. So it's just this number divided by this number, which makes it very simple. So here the mean is about 7.41. Now, if you want to find the median of data like this, where you have heaps and heaps of data, a good formula is n plus 1 on 2. So n is the number of scores. Now this formula, n plus 1 on 2, doesn't tell you what the median is. It tells you which score is the middle score. So here there were 29 scores. So 29 plus 1 on 2 gives you 15. The median of these numbers here is clearly not 15. It can't have a median of 15 when the highest score was 10. 15, though, tells you which score is the median. The median of this data is the 15th score. Whether you consider it the 15th largest or 15th smallest doesn't matter. So what I'm going to do now is I'm going to go to my frequency table and I'm going to fill in this column, CF for cumulative frequency. So that tells us how many scores are less than or equal to that score. So the number that goes in the first one is 1. There is one score that is 3 or less. Then 1 plus 3 gives us 4. So there are 4 scores of 4 or less. And then I go 4 plus 2 is 6. There are 6 scores of 5 or less. 6 plus 3 is 9, and so on. So this is like a cumulative frequency table. This is the cumulative frequency column. Again, this number, for example, means there are 19 scores that are 8 or less. So when we're finding the median, we wanted the 15th score. So what this cumulative frequency column tells us, there are 13 scores of 7 or less, and there are 19 scores of 8 or less. So that means that the median score, the 15th score, must be 8. That is the median of this data. So the fx column helps us find the mean by helping us sum up the scores nice and easily, and the cumulative frequency helps us find the median by telling us how many scores are less than or equal to a particular score. So another thing you might be asked about data like this is to comment on the skewness. So skewness is about where the scores are clustered. So if I have a histogram that looks like this, we say that the data is negatively skewed. If it looks like the second one, it's positively skewed. And if it looks like the third one, this data here is not skewed at all. We say it's symmetrical. And you can see here that for this data, it is basically symmetrical. There's like a line of symmetry there. The data doesn't have to be exactly symmetrical. What we mean here is that the highest frequency scores are in the middle. For positively skewed, the highest frequency scores are closest to the minimum, And for negatively skewed, the highest frequency of scores are closest to the maximum. So be careful with negative and positive skew. It sort of goes in the opposite way you'd expect. You'd expect negatively skewed would have more lower scores, but it's the opposite. Negatively skewed means more higher scores, more scores closer to the maximum. So if I were to put this data here into a histogram, it would look like this. So when you're drawing a histogram, frequency is always on the vertical axis. Here, F and X have the same meanings they did in the frequency table. So there were no scores of 1 or 2, there was one score of 3. So you start the bar here at 3, and that bar there means one score of 3. There were 3 scores of 4, so we draw a bar up there, and so on. So we can see from the histogram, this data is like this one, negatively skewed. The highest frequency scores are closer to the maximum. All right, now we need to take a look at grouped data. So let's say I have this data here. So I actually got this from the Brisbane Broncos website. This is the number of games played by each of the 13 players who started last weekend. So they go from 3, their fullback, and only played 3 matches, up to 324, Darius Boyd, their centre. So how am I going to display this information in a useful way? Well, if I were to try and draw a histogram, what's it going to look like? I'm going to have 3, 4, 5, all the way up to 324. Well, that will take forever and won't provide any useful information because 3 is the only score that was repeated. So, I'd have a bar up to 2 for 3, and then, I'd have all these bars along here like that. Really wouldn't help. So let's say instead of drawing a histogram, I want to put it in a frequency table. But again, it's just going to take forever and not provide any useful information if I go 1, 2, 3, 4, all the way up to 324. Instead, what I'm going to do is I'm going to group the data. So for a data set here, I'm going to group in 50. So just like before, I'm going to have a column for X, which is the score, and F for the frequency. So my first group, I'm going to write like this. So this reads, X is between 0 and 50. It includes 0, because it's less than or equal to, but not 50. So this includes all the people who've played between 0 and 49 games inclusive. So the next group would be 50 is less than or equal to X, which is less than 100. We read that X is between 50 and 100. This time it includes 50, but not 100. And we'll do likewise for the next few groups. So let's go and find the frequencies for each of these groups. So the first group is the people who've played between 0 and 49 games. So it includes these 3, it includes these 3, and these 2. So we can see that there are 8 people in this group. So the next group are all the people who've played between 50 and 100 games. So that's just this person here. And we do so similarly for the next groups. So the sum of all of these frequencies we write down here as 13. So there are 13 scores in total. So this is a much more convenient way to display the information when there's a large range in values. So let's now get rid of these data values. And let's say we just have here a grouped frequency table. If we don't have the individual data points, how can we calculate the mean and median? Well, the short answer is you can't. You can't calculate the mean and median, but what you can do is estimate them. And this is how you estimate them. First, we're going to write the midpoint of each interval. So this is an interval here, 0 to 50. So halfway between 0 and 50 is, of course, 25. Halfway between 50 and 100 is 75. Then 125, and so on. So if you have a grouped frequency table like this and you don't have the individual data values, the way you estimate the mean is you sort of pretend that each score in this interval here is equal to 25. Of course, without the data up here, we don't know are these 8 scores. They could all be 0. We could have scores of 10, 20, 30, whatever. We don't know what the individual scores are. So we're going to pretend that each of them is equal to the midpoint, which is 25. So in this next column, 8 times 25. And similarly, the next one is 1 times 75, and so on. So, of course, we have a 0 here because 0 times 225 is 0. So now let's add up all of these as we did on the previous slide. So in doing this, we're estimating the sum of all the scores to be 1175. So our estimate of the mean, I'm just going to put the star there because it's just an estimate, is 1175, the sum of all the scores divided by 13. And that gives us approximately 90.4. So that is our estimate. The mean number of games played by these 13 players is 90.4. Again, it's just an estimate. So let's now look at the median. So there are 13 scores. So using the formula from last slide, n plus 1 on 2, that would give us 14 on 2, which is 7. 7 is not the median. The median is the 7th score. So once again, we can create a cumulative frequency columns. There are 8 players who've played fewer than 50 games, and 9 that have played fewer than 100, 10 that have played fewer than 150, and so on. So if I want to find the 7th score, well, it's actually in this group here. The 7th lowest score will be in the first interval. So my estimate for the median is going to be, because it's in this interval, it's going to be the midpoint of that interval. So again, this is just an estimate that the median is 25. Half the players have played fewer than 25, half have played more than 25. So that's how you estimate mean and median from a grouped frequency table. Now, we probably don't need to transfer this into a histogram for you to tell whether or not the data is skewed. So we can see that there are many more scores closer to the minimum. So the data here would actually be positively skewed. We can probably tell that without a histogram. But if we were asked to draw a histogram, it would be a grouped histogram like this. So this is how we draw it. So there were 8 people between 0 and 50. So the bar goes like this. It ends at 50. Then the next bar starts at 50, was 1, and it ends at 100. So after 100, the next bar had 1 people in, ends at 150. Then from 150 to 200, there was another 1, it ends at 200. 200 to 250, had none. Then the next bar starts at 250, and the last bar starts at 300. That's what the grouped histogram would look like. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.